Well, welcome back. As promised, we're going to put together this PID. Now, we're going to put together the basic model. We're not going to sex it up with anything else. We're not looking for any cool points. We just want to put together a system, a small controller that works, and you can utilize it anytime you want. You can control your still. You can have that precise control, so you'll know at what temperature it's at, and it'll go only what temperature you want it to go at. Plus, we're going to describe, of course, we got the whiteboard. We're going to describe a few things that you need to understand. Now, let's take, for instance, look, we've got all of our stuff together. I wanted to show you this. This is what I'm working on. This is a controller, and I'm using these square. This is for the 15 amp. I'm using these square sockets, and I cut holes in here, and I'll put them in. I put some buttons, button to operate the PID controller, one to operate the water pump. There you go. What I used for that, and see, I've got a hole cut here for my PID. It slides right in there, nice and tight, and it goes all the way through. So that's what it looks like. And then, of course, I cut a hole for my amp meter, but you don't have to do that. We're going to concentrate on just the PID and the basic model. Now, what I used to do that with, and of course, after I cut the first one and got it right, I just made some guides. That's for two of my plugs. That's for just one PID. That's for two PIDs. That's for the one that we're going to make. Really is going to be the PID, a control switch, and the receptacle. So we're going to do that. And what I used this neat little thing, is this little gizmo I got this at Harbor Freight. It cost me probably about $13, $14. It's like a Dremel. I've got a Dremel as well. I use both of them. I've got different blades on them, but I got this small saw blade, and they sell a pack of them there for like $5. You got different sizes. And I use that just to cut the holes in there, and at the very end I just use a X-Acto knife, and that's what you just use, shear off the edges and just make it nice and smooth. So that's what we got. So let's put this aside, and let's say now that you've got everything you need. You've got your PID, and I've got a PID up here on the wall. All right, I've got the 20 amp, 120 volt, and I just default to the 20 amp just because I know I'll never reach 20 amps, but to me it's just a whole lot safer. It gives me options. And I've got one of those up here. I've also got the switch. I got that laying around here somewhere. Then I've got my solid state relay, and you'll notice I got one of those up on the wall. And of course we got our little test lamp that we're going to use, and we'll hook that up at the very end just to prove that it's actually working, that the light's coming on and going off at the appropriate times. And then I've got my K-type coupler, and I'm going to use the one with the long probe on it. You can use a short probe, it makes no difference. So I've got all my equipment. Now, one thing I wanted to share with you, I got this Small Uglies magazine. You can find these Lowe's, Home Depot has them. They're hanging on the wall there. I can't remember. They're like maybe $8. But it's an electrical reference guide. And some of the stuff I'm going to talk about is in this. There's no way in the world you're ever going to, if you know all of this, you need to be in a university somewhere as a PhD teaching this stuff. There's more information in here than you can shake a stick at. I probably understand and know maybe 1% of what's located in here, but this has everything from formulas to wire sizes to switches to wire and motors to wire. This will really help you out a whole lot. It's one of those, it's nice to have, you don't have to have it. But if you ever have questions about electricity and what's going on and how to make things work, it's usually, you probably find it in this book. And of course I got the calculator. And calculators for all those formulas that we're going to talk about. Now, remember I said we're going to use the 15, we're only going to do a 15 amp circuit. I'm using a 20 amp receptacle, but I'm using a 1500 watt 120 volt, and the 1500 watt 120 volt is actually 12.5 amps. Now, we'll get to about what's important about that in just a second. But I wanted to show you something. I've got three conductors here, better known as wires. I've got a 12 AWG, American wire gauge. I've got the 14 AWG, American wire gauge, which you'll find running through most of your appliances in your house, lights and things like that. The 12 is normally reserved for things like, your coffee pot and stuff like that. You got an 8 that goes on your stove. And then I've got the 16. And the 16 is normally used for signaling. Some 12 to, maybe 60 volts of DC current. You can run AC current through them. It'll carry current as well, but it's a low current. So your 12 AWG, American wire gauge, is rated for 20 amps. So if we were going to put together a system that was going to operate, and we knew it was going to operate up to about at least 20 amps, or short of 20 amps, more than 15, we would use 12 gauge wire in order to be safe. Because remember what I told you about that was that amperage, excess amperage that it's rated for is going to be dissipated as heat. And if you put too many amps through that wire, it'll just start to melt. And you don't want that to happen. Now you got a fire hazard, you got all kinds of safety issues. Now your 14 gauge wire is rated up to 15 amps, which that's the one that we're going to use primarily in our circuit. We're going to use a 15 amp. I will use some 16, and I might even use 18, which is a lot smaller, but that's for the small signals that go between the PID and the control and the SSR. We'll get to that. Now, here's what we need to understand about just basic electricity. If you know absolutely nothing, if you do know everything about electricity, please skip through this. But if you don't, just a real quick recap. You got 120 volts. You're going to normally have in your system, you're going to have a black wire. Then you're going to have a white wire. And I'm going to use red because you wouldn't be able to see white if I drew up here. This would be your white wire. And then you're going to have what's known as the green wire. This is the ground. And everybody's aware of ground. Okay. Now, what this is called the hot wire. Now, you do know that AC, alternating current, goes in both directions. But it's peaks and valleys. It's a sine wave. But it actually goes in both directions. Now, the white wire is known as the neutral wire. So what we have now is we have the potential difference, or the voltage. Let's just look, if you measure between this wire and this wire, you would get 120 volts. That's what that indicates. So you got a hot wire and you got a neutral. So you got a path for electricity to go through. That's 120 volts. Also, if you connected a multimeter from the hot wire to the ground wire, you'd also have 120 volts. But your ground wire is for safety. That's just in case something happens, you get a short circuit, it grounds itself out. Your neutral is also hooked to a bus bar. This is known as a common ground to measure from, and it also gives electricity a path to flow through back through your control box, through your fuse box. All right, now we're going to hook this up as a 120 volt circuit. Now, here's the things we do need to realize, we need to understand. Now, if we're using 120 volts and we're using a 1500 watt heating element, and heating elements, and they're rated as in watts. It's just like a light bulb. A light bulb, you got a 40 watt light bulb, a 60 watt, you got a 100 watt light bulb. Well, heating elements, wattage is power, is the measurement of power. And it's all based on resistance and based on a whole bunch of other formulas. The one that's important to us is amps. How many amps are going to be drawn through that circuit in order to operate that 1500 watt heater element at 100%. This is our heater element. This is the same element that goes inside a water heater. And they come in many different sizes, many different styles, and made of many different materials. But the most basic one here, this is $8. So it's 120 volt, 1500 watt. You'll know that because it says so right on the side. It'll tell you that. There you go. And so we've got a hot, a neutral, or you can do a hot and a neutral because it doesn't matter. It's not polarized. It doesn't care. All it wants is electricity to flow through this and heat up because of the resistance. And then you've got one ground. And that ground is only for safety. So make sure you always use a ground. So here's what we need to know. We need to know that if it's 1500 watts, and we're going to run 120 volts through it, here's what we know. We know that watts divided by volts equal amps. And in this particular case, it's going to be 12.5 amps. So we know that. We know that at peak usage, when it's on 100%, it's only capable, because of the way it's designed, its resistance, it's only going to operate at 1500 watts. Now, of course, that's give or take. There's always going to be a little bit of fluctuation in there. But we know that. And we're only going to use 120 volts. So if we divide 120 volts into the 1500 watts, the most that we could possibly expect to run through our circuit is 12.5 amps. Now, we're running off of a 15 amp circuit within your home. So make sure you kind of isolate everything and try to use just that one plug. So that way you get all the amperage that's available, because if you hook up more, guess what's going to happen? You're going to blow the fuse in the fuse box. Then you're going to start unplugging things, and you're going to flip the fuse back on to get back to work. So kind of isolate that at the very beginning. So in that circuit, we're only going to run 12.5 amps. We're not going to reach the 15 amp limit. So the circuit's not going to blow, and we're going to get 100% operation out of that, from 0 all the way up to 12.5 amps. Make sense? Real simple. All right. Now let's move on. This is the standard plug, and what I've got here is I've got the 3 wires that come out. Here's the white. Remember what the white was? The white is the neutral line. It doesn't carry voltage directly. Let's not get too technical. It doesn't carry voltage directly. It does kind of indirectly, because it causes a path. And this is the black wire, which is known as the hot. And your hot wire is what's carrying the initial blast in that sine wave of 120 volts. And that's this wire. And of course, this is your ground, the green wire. And so that's sort of like, that is the convention. Everybody knows that when they see a black wire, it's a hot. The white wire is a neutral. They know that the green wire is a ground. It's kind of, that's a given. All right. Now we know all of this. What I've already done is I've already taken and I've already added 2 other little pigtails with a wire nut to this green, because I'm going to connect that to the ground, and the ground on the switch. And I'm also going to connect it to the ground lug on the receptacle. And what that does is it secures my system. In the event that something should go wrong, very unlikely, but in the event that it does, it's going to give this electricity a path back to earth ground, and that path is going to prevent it from going through us. So that's what it's for. And then our white wire is going to go to the neutral side of our switch. Our black wire is going to go to the hot side of the switch, or the receptacle. But it's not going to get, it's going to get there through the switch. Now see, that's how you operate switches when you turn the lights on and off. Your black wire and your white wire is connected to the socket, but that black wire is broken because it goes to the switch first. We're only going to switch one wire. You only need to switch one wire. So you'll notice on this switch, and this is just a simple on 15 amp on off switch. It's only got 2 screws on it. 2 screws, and it's got one green one, and green is ground. Okay. So what happens is when it's in the off position, these 2 screws are separated. They're separated physically, which means no electricity can pass. But if you hook a wire to the bottom, 120 volts to the bottom, and then run a wire out from the top to whatever your device is, right now they're separated. If you flip the switch on, these become connected. So that means now you've got, it's just like having a wire running right next to it, going straight to your device, and it operates, it's on. When you turn the switch off, these 2 separate. When they separate, the light goes out. So that's how a switch actually operates. And there, you'll notice that as well. Now, something else that's interesting to know too is that if they're brass or goldish, a gold color or brass color, it normally indicates hot. That's the hot. If they're silver, that's normally the neutral. That's another convention that you just kind of get used to. And it's a little bit, it's a whole lot easier to follow. And the green, of course, is ground. Now, we've got our plug, the receptacle located here, and we're going to energize that receptacle and the PID with this on-off switch. Now, when we do this, remember I said that the brass would indicate the the hot, there we go, and the silver indicates the neutral. And you'll notice on this plug, now this is the 20 amp. You'll notice it's a 20 amp because you see that slot there. That's how you can tell almost immediately the difference between a 20 amp and a 15 amp because it has that extra slot. And it's also a little bit larger. Now you got the brass ones on one side, and that brass one goes to the smaller slot. Another convention. Your hot is normally the smaller slot, and your neutral is normally the larger slot. Turn it over to the neutral side, voila, there's silver screws. So you got the brass screws for the hot side and the silver screws for the neutral side. And of course, you've got the green screw for the grounding lug. That's why I have the pigtail here, and this pigtail is going to connect to this green screw and to that green screw, which is going to ground our system. Now, here's one other additional thing I want to show you. Remember, we're going to wire up just the very basic model. And meaning the very basic model, meaning we're not going to add nothing extra to it. Now, but if you want to separate this receptacle so that you can operate a water pump from the lower receptacle and your heater element from the upper receptacle, I'll show you how to do that. Or you can do the heater element from the bottom and your water pump from the, it's totally up to you. But once I show this to you, it'll set you free. This receptacle, once wired, if you put a hot wire and a neutral wire, both receptacles are going to be functioning. They'll both function. But we want to make one function separate from the other. So what we want to do is we want to isolate them. Here's how that happens. Now, look at this real closely. Okay, so you got the hot side and you got the neutral side. Now, let's go over here to the hot side, and you see you got the two screws. You got an upper screw and a lower screw. If you want to energize this entire receptacle, you only need one wire at the top because it's connected. It's connected here. You see that plate that goes across both of them? And there's your bridge right in the center. That bridge in the center makes sure that this screw and this screw are connected all the time. Now the same thing on the neutral side. You got another bridge, and that bridge connects this screw to this screw. So they're connected all the time. Now just follow this. If they're connected all the time, you only need one hot screw and one neutral screw. And that means that this plug, this receptacle, is hot all the time, both the top and the bottom. Now, if we want to separate these two, we want to isolate the top from the bottom, then we somehow have to separate those connections. And in order to do that, you just take a small pair of wire cutters, and on the hot side, let me get over here. Yeah, on the hot side where the brass screws are, if you'll just take a pair of wire cutters and you clip this right here and you separate, what you're doing is you're separating this screw from this screw. And you're going to isolate the top and the bottom of this receptacle. Now, you could also, at the same time, separate this side, but that's not necessary. I mean, if you did, then that only means that in order to operate the top, you'd have to put a black wire, hot wire, and a white wire to operate the top, then a black wire and a white wire to operate the bottom. So the top switch would work on one circuit and the bottom switch would work on another circuit. But here's your option. Since you know that the hot wire is the one that we switch and the neutral wire is neutral, if you only clip the hot side, which is this one with the brass screws, if you clip that one, you isolate the top from the bottom. Leave the other one connected. So you'll only need a hot wire for the top circuit with a white wire and a black wire for the bottom circuit, and that white wire, since it's still connected here, will operate that bottom switch as well. So it just, all that does is save you an extra wire. Do it either way, it doesn't matter. You can clip both or you can clip just one. If you're going to clip just one, only clip the hot side. That's the side that you switch. So we're going to leave ours alone because we're going to hook, like I said, we're going to hook up the base model only. So every time our PID operates and energizes, it's going to energize both the top and the bottom switch. All right, we're there. Now, in addition, what we'll do is we're gonna switch the hot from the switch, and then we're also going to make sure that we connect our white wire, which is our neutral, to the receptacle. But we're going to switch it from here, the hot wire from here, through our SSR to the receptacle. Now here's how that happens. See, I told you, I like to explain as much as possible without boring you to death. And if I'm boring you, please just flip through it. Maybe you have to come back and catch up with it. But here's the reason why we do that. Your SSR operates by 3 to 32 volts direct current, and your PID is going to put out 24 signal. It's going to put out a 24 volt signal. And that signal is going to go into pins 3 and 4. And every time that signal, those two wires that go right in there, every time that signal comes on, that light right there is going to come on. And that light's going to operate this circuit up here, because this is a solid state circuit. It's a relay. But it's not a mechanical relay. If it was a mechanical relay, it's going on and off so many times, it'll eventually burn. You know, it's like an old points in a car. You know, you always had to take them out and file them down and clean them up because they would burn, because there's always a small spark. Well, this is done internally, and it's done so that there's no spark and there's no mechanical contact. So through pins 1 and 2, if you hook a hot wire to pin 1 and the other portion of that hot wire to pin 2, that wire only becomes hot when the signal goes into pins 3 and 4 and that light comes on. When that light comes on, current is flowing between these two pins. And if current is flowing between these two pins, then it's energizing this receptacle. You see how simple that is? We're talking about bringing in power, leaving power here that's going to be switched electronically to energize this. So all we got to do now is connect it to the PID and let the PID know, hey, I want you to turn it on and I want you to turn it off when it's appropriate to make that thing work so that my heater element gets hot and it doesn't get too hot and it doesn't stay too cold. And your PID is going to do that all by itself. So we've got the basic understanding of that. And this is, believe it or not, so simple to wire. Once you get this, and I recommend you put it on a piece of wood, screw it down and get it right, and then take it off and put it in your box. It'll set you free. Now, on our PID, you've got, oh gosh, you've got this list on the side that's got all of this data and all this stuff, this information that tells you what to do. It tells you where everything goes and what each one of these pins do. You just need to know that you're only going to use, believe it or not, you're going to use pins 1 and 2, 3 and 4, and you're going to use pins 7 and 8. And I'm going to show you why. Those are the only, first of all, those are the only ones you need. That's not all that this PID can do. That's all we want it to do. We want to be able to control that. So you've got pins 1 and 2, and it says 9 to 260 volts for pins 1 and pin 2. And your PID doesn't care whether that is black or white or black. If you turn it over on the bottom, you see you got a whole bunch of screws. If you look along the side here, there'll also be a real small indentation. They're numbered 1 through all the way through 12. Some PIDs will come with missing screws. That's because it's a limited function. But all of them will come with enough screws for what you want to do. So we would hook pins 1 and 2 to a hot and a neutral. 3 and 4 is our signal pins. And then what did we say it was? I'll look on here because it says TC thermocouple. And it has pins 7 and 8. And that's listed right there, so you'll see that. TC thermocouple pins 7 and 8. And you'll also notice that they are polarized. 7 is negative, 8 is positive. So it makes a difference on the thermocouple. Here's a point for point of reference. The thermocouple. If you hook the thermocouple up backwards and you grab a hold of it and it starts to sense your temperature, and you know the temperature is supposed to rise, you're at, let's say you're at 50 degrees or 15 degrees Celsius or whatever you've got it set at before you get it actually all set up, and you grab a hold of that thermocouple And you know it's supposed to go from 15 to 16 to it's supposed to go up, or 50 to 51 to 52 to 53. If you grab that and it goes 50, 49, 48, or 15, 14, 13, you got it backwards. Take these off, switch them, put them back on, grab it, and you'll see that it goes the other way. So your thermocouple works both ways. It doesn't care, it's just going to operate, but you just got to make sure you plug it up the right way. So normally the red one in this particular case is the negative, and the blue one's going to be your positive. But you never know when they put them together, and since it doesn't matter, the thermocouple's polarized, but it doesn't care. The only thing it cares is your PID. So keep that in mind. Now look, I'm going to cut some wire and get things together and get ready, and then we're going to walk through this step by step, and we're going to start to connect all of this together, and we're going to do it step by step so it makes perfect sense. And then at the very end, we're going to turn the light on, we're going to turn on the PID with the switch, and we're going to make this thing work. How's that? Stay with us, and we'll be back shortly.